exploring the insides of the atom. This is found on page 18 of your textbook. Discovering the heart of the atom. Before we read any further, let's take a look at what's on our screen right there. The caption reads, Rutherford observed that when he shot A particles at a piece of gold foil, they mostly passed straight through it. But when they occasionally hit the nucleus at the center of a gold atom, they bounced back, just like a bullet hitting a small, heavy, hard object. Discovering the heart of an atom. In the early 1900s, the British physicist Ernest Rutherford was conducting an experiment. He fired positively charged particles called A particles and an extremely thin film of gold foil. The foil was only a few atoms thick, about 100 times thinner than a cotton fiber. Rutherford and his team expected to see the A particles go straight through, the same way a bullet would penetrate a piece of paper. However, his team observed a different pattern. Most of the A particles went through, but a few bounced straight back. This could only happen if an A particle had hit something much heavier than it was. Rutherford said, well, it was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came right back and hit you. Why did the A particles behave this way? Rutherford concluded that most of the matter of a gold atom was concentrated in one tiny place, which he called the nucleus. The rest of the atom was mostly empty space. Most A particles passed through the atom without hitting the nucleus. When an A particle hit the nucleus, it bounced back, like a bullet hitting a small, heavy object inside the atom. Here's the caption again. Rutherford observed that when he shot A particles at a piece of gold foil, they mostly passed straight through it. But when they occasionally hit the nucleus at the center of a gold atom, they bounced back, just like a bullet hitting a small, heavy, hard object. Ernest Rutherford discovered that atoms were mostly empty space with a nucleus of protons surrounded by orbitals of electrons. Mostly empty space. Rutherford wondered, what is the nucleus made of? He thought it could be made of positively charged particles called protons, negatively charged particles called electrons, or a mixture of both. If the nucleus was made up of only electrons, then the positively charged A particles would stick to the nucleus, similar to how different poles of two magnets attract each other, instead of bouncing back. If the nucleus was made of protons, or a mix of protons and electrons, the A particles would bounce off when they hit the nucleus directly. However, this would not explain how the A particles changed direction slightly. This could only happen if they were being repelled by a positively charged nucleus. Rutherford concluded that an atom was made of a nucleus of protons surrounded by electrons scattered throughout empty space. Using these new conclusions, Rutherford proposed a model of the atom that is similar to the solar system. The nucleus represents the sun, and the electrons represent other celestial bodies scattered in empty space around the sun. Scientists today agree that most of an atom is empty space. If you had an atom of gold that was the size of our solar system, the atom would have a nucleus the size of the sun. Almost all of the matter would be contained within that nucleus. Its electrons would lie in space in orbitals that grow larger and larger. The farthest electron would be found far past our most distant planet, Neptune. Though a solar system model does not show all of the characteristics of an atom accurately, it does give you an idea of just how much empty space there is in an atom. An atom, like a solar system, is made mostly of empty space. A nucleus of a carbon atom is 100,000 times smaller than the entire atom. In a solar system, the sun is more than 800 times smaller than the entire solar system. In this picture, you'll see where the model of our atom is at the top, and it shows the nucleus in the middle, and then it shows the model of the solar system down below with the sun in the middle. And in both cases, the nucleus and the sun are much larger than those things that are spinning around it. Let's read about atom smashers. Scientists did not stop investigating the atom after Rutherford's gold foil experiment. While they knew that atoms were mostly empty space with protons and electrons, they wanted to gather more data about these particles through experiments. But how could they study minuscule, that means really small atoms, that are tens of thousands of times smaller than bacteria? The atom's electrons can be thousands of times smaller than the atom itself. In order to study the insides of a nucleus, scientists decided to smash them open. Suppose you opened a computer and looked inside. You'd observe that the computer has metal chips and wires, and that the wires connect different components together. Scientists wanted to similarly open an atom. However, an atom is too small to easily open. Instead, the only way they could open an atom was by smashing it open. Unlike carefully opening a computer, smashing an atom would not give a clean picture of the insides. Nevertheless, scientists could study the pieces that they got after smashing apart a nucleus to learn more about it. They could use the broken pieces of the inside of a nucleus as evidence to make predictions and speculate about how the insides of a nucleus would look if it was not broken. To study the insides of atoms, scientists will build particle accelerators. Particle accelerators are machines that shoot tiny particles at very high speeds to smash apart atoms. Here, a scientist checks the magnets of a particle accelerator. In the early 1930s, scientists built the first particle accelerator to smash atoms. A particle accelerator is a machine that shoots tiny particles, such as protons, at high speeds. As a particle travels through the accelerator, magnets pull it along so that the particle moves faster and faster. Once it has reached a high enough speed, scientists put a nucleus in the particle's path. The particle hits the nucleus, and the nucleus breaks apart. Then they can study the components of the atom. Let's read the caption here. The largest particle accelerator is the LHC, and it's located at the border of France and Switzerland. The LHC is a huge machine, 27 kilometers long in circumference. Here, a person stands inside of the LHC, and if you can see it, this is where he's at right here. And this whole tunnel is 27 kilometers long, about 20 miles long. Particle accelerators used to study the insides of a nucleus are very difficult to build. The particle needs to be moving at a very high speed when it hits the atom so that the atom will break apart. To build up enough speed, particles need to travel long distances. One method of building particle accelerator is to construct a linear one. That's a straight line. In a linear particle accelerator, most of the machine stretches out in one long line. The longest linear particle accelerator is 3 kilometers long machine at Stanford University in California. 3 kilometers is about 2 miles. Straight line. Imagine that, a machine 2 miles long. However, this is not the largest particle accelerator. There are larger particle accelerators that are circular loops. The particle can spin around the loop for as many times as it needs in order to build up enough speed. For many years, scientists worked together to build a particle accelerator called the Large Hadron Collider, or LHC. The Large Hadron Collider is actually a circle that is 27 kilometers in circumference and located in Europe at the border of France and Switzerland. Scientists from all around the world gathered together to build the LHC, and now they take turns using the LHC to conduct their experiments. Scientists first started using the LHC in 2010. And there's the caption for it again. The largest particle accelerator is the Large Hadron Collider, located at the border of France and Switzerland. The Large Hadron Collider is a huge machine, 27 kilometers long in circumference. As years pass, they continue to improve the equipment and experiments. There is an international excitement to see how this enormous accelerator and any new ones that might be built in the future will help the world to understand the tiny atom.